We say that two integers are relatively prime if their greatest common divisor is 1. So for example, if you were to look at 16 and 49, okay, neither of which are prime, but they don't have any common factors in prime. In particular, their greatest common divisor is 1. Okay, so relatively prime means that the GCD is 1. There are a few other notions of relatively prime that we should talk about. If you have some integers, I'm just going to do this for 3. In general, this will be written up in the lecture notes, how to do this for a general number of integers. But if the GCD of A, B, and C are 1, then we say that A, B, and C are relatively prime. Okay, so these are relatively prime. And that means that there's no prime factor in common with A, B, and C all at the same time. This is in contrast, though, to say that we say that the 3 integers A, B, and C are pairwise relatively prime. So they're pairwise relatively prime if the GCD of all 3 pairs, there's 3 numbers here, so we have 3 pairs, if the GCD is 1. So GCD AC, GCD BC. Okay, this is a stronger statement than relatively prime. In other words, there are integers that are relatively prime that are not pairwise relatively prime. For example, notice that if you were to have, say, 6, 10, and 15, these are integers that are relatively prime. There's no integer, there's no prime that divides 6, 10, and 15 all at once. They're relatively prime, but not pairwise relatively prime. Because if you look at, say, the GCD of the first 2, that already breaks it. So to be relatively prime means that all of these, you have to have this GCD is 1, and this GCD is 1, and this GCD is 1. Okay, so 6, 10, and 15 are not pairwise relatively prime because, for example, the GCD of 6 and 10 is not 1, it's 2. So that's relatively prime and pairwise relatively prime in a nutshell.